section 14.4, we're going to talk about measures of spread. Measures of spread are exactly what they sound like. They measure how much data set is spread out. So when I tell you the measures of center, like the mean, the median, and the mode, you don't get a sense for how spread out that data actually is. You only know where our supposed center is. So for all we know, when I tell you the mean is, 27.9 years for our age data, all of the students in the class could be within 2 years of that or 5 years of that. Or maybe they could, be much more spread out than that. So it's really good to know a little bit more about the measures of spread. Two of them that we're going to talk about are pretty simple and straightforward. The third is just a little bit more complicated to calculate. It's really not hard. It just takes several steps. First of all, the range. The range of a data set is the amount of values covered by the data. So to compute this, we're just going to take the max minus the min. So if you recall our age data, that our oldest person was 56 and our youngest person was 18. So if I calculate that, that's a range of 38 years. So that gives us an idea of how spread out those data are. The second one that we can look at is called interquartile range, and we mentioned this with regard to outliers in the last section. So we call this IQR, and this is quartile 3 minus quartile 1. The third and more involved calculation is for standard deviation. This gives a lot more information about the data. It really tells us a lot about the spread, not just the min to the max, but also kind of an idea of how condensed they are. So our max of 56, well, that could be way out there compared to the rest. Standard deviation is going to allow for a much more accurate representation. So this output, it's going to be a single value, and it's going to tell us something about the spread compared to the mean, and we're going to talk about both what it tells us and how to calculate it. So for starters, to calculate it, you're going to want to follow along in the notes that you can print off with this so that you make sure you get all the details. So first, we find the mean of the data set. Second, we calculate what's called the deviation from the mean. So you take the data value minus the mean. And it doesn't matter whether this comes up positive or negative. In the end, we're going to square it, so it doesn't matter. Usually, this is best done in a table. So from here on out, we would work with a table for all the rest. The third thing we do is we square these deviations. So we square the above. The fourth thing, we add up all the above from number 3. So all of those squared data, the squared deviations. And then we divide this sum by n, where n is the number of data values that we have. The very last step, we take the square root of whatever our answer is. Now that's a lot of steps, and they probably don't make a whole lot of sense right now. So let's look at our example of our age data and calculate this. Again, you're really going to want to have your notes open and available so that you have these steps all laid out for you. All right, here's our age data. I've already put everything into this table, but I want to explain it. So the first column here is all the data themselves. So remember, we had 18, 18, 19, 20, 20, 20, etc. So those should all be the same as we've been working with in the last couple sections. The next thing we did was we took the data value, we called it x, and we subtracted the mean. So 18 minus the mean of 27.9 is negative 9.9. And we got all those values, so we calculated for the whole column. The next thing we did was square each of those, so we took negative 9.9 and squared it, and so that's why it doesn't matter whether it's negative or positive, because when you square it, they all turn out positive. So you can see the closer we are to the mean, like a value of 28, we get a very low squared deviation. And when we're up here at 56, we get a really high squared deviation. So the next step is to add all these together, and when I did that, I got 1532.95. Then we are supposed to divide by the number of data points. If we count them up, there are 15 of them. So we're going to divide by 15. And we get 102.2 if we round it to the nearest tenth. So the last step is to take the square root of 102.2, and we get 10.1. So this is the standard deviation of this data. And what does that mean? Well, we're going to look at this a little bit more in chapter 16, but for now it tells us how spread out the data set is. And we can use them to compare data sets right now. Our data is spread out at about 10 years. It means most of the students fall within 10 years of the standard deviation. Let's take a look. So within 10 years of the mean. So the mean is 27. So that would be between 17, that's 10 below, up to 37. And so within 10 standard deviations of the mean, most of the data fall within that. So the mean is right about there. That's the mean, somewhere right in here. And so we can see that that's true here. Now, if we took out 56, we would get a much lower standard deviation. So the fact that we have this outlier 56, it makes our standard deviation higher, which means we're going to have even more data within one standard deviation of the mean because of that. But that gives us a really good indication that we are a little spread out in the data. And if I had another class that I took this data on and their standard deviation was only 5 years, then I could tell that they were much less spread out. So they were much closer to their mean than this particular set of data are. Now you can do this calculation on your calculator. You can find directions if you just Google your particular type of calculator or something to find the standard deviation. Generally speaking, you put your data in a list of some sort. This, I believe, works mostly on graphing calculators. You might be able to do it with some online graphing calculators or something like that. But you need some way to put it in a list and then ask for the standard deviation. So you are allowed to do that for homework and whatnot, but you are responsible for knowing how to do the calculation by hand. Now, I'm not going to ask you to do it with 15 data points. You'll notice if you look at the homework that you have more like 4 data points. So you can see how this would be much more doable with 4 data points. Find the mean, take the 4 data points minus the mean, square it, add them together, take the square root. It's really not a complicated process. So to recap, in this section you know how to need to take the range, the interquartile range, and the standard deviation all by hand. You are responsible for doing them all by hand. That's all there is to this section.